Determine the system of inequalities that gives the provided solution. Looking at the graph, the shaded region is part of the solution, as well as the border because both graphs are solid. Because both graphs are solid, we know the system of inequalities must have less than or equal to or greater than or equal to inequality symbols. And now let's focus on the parabola first. Notice how the parabola opens down and the vertex is this point here, the highest point on the graph, with the ordered pair 2, 5. The vertex form of a quadratic function is y equals a times the quantity x minus h squared plus k, where if a is negative, which is our case, the parabola opens down and the vertex is h, k. So we know a has to be negative, and because the vertex is 2, 5, the inequality must be in the form of the quantity x minus 2 squared plus 5, which limits us to these first two inequalities, or these two inequalities here. Notice how for these two inequalities, the vertex would be negative 2, negative 5, which is not the vertex. And now because the region is shaded below the parabola, the correct inequality must be y is less than or equal to the opposite of the quantity x minus 2 squared plus 5. So the second inequality must be one of the inequalities to the system of inequalities. And now looking at the next group of inequalities, we first need to figure out which related equation would give us the graph of this red line where the vertical intercept is 0, negative 3, the horizontal intercept is 6, 0, and the slope is 1/2. So notice how the related equations would be x minus 2y equals 6 and x plus 2y equals 6. So to figure out which of these would give us the graph of the red line, we could solve for y and write the equation in slope-intercept form, but since we already have the equation in standard form, let's go ahead and find the horizontal and vertical intercepts for both equations. Remember, to find the vertical intercept, we set x equal to 0 and solve for y, and to find the horizontal intercept, we set y equal to 0 and solve for x. So for this first equation, when x is 0, we have the equation negative 2y equals 6, and therefore y is negative 3. And when y is 0, we just have x equals 6. For this equation, when x is 0, we have 2y equals 6, and therefore y is 3. And when y is 0, again, we have x equals 6. So again, because the vertical intercept is the ordered pair 0, negative 3, this equation gives us the graph of the red line, and therefore we only have to consider these first two inequalities. We need to be careful when selecting the correct inequality here. Because these are not solved for y, we cannot just say because we shaded above the line, we select the inequality with a greater than or equal to inequality. We need to select a test point from the shaded region and see which inequality it satisfies. Let's go ahead and select this point here where the ordered pair is 2, 0. So we'll substitute 2 for x and 0 for y, and the inequality x minus 2y is less than or equal to 6, as well as x minus 2y is greater than or equal to 6. So again, we substitute 2 for x and 0 for y. We substitute 2 for x and 0 for y here. We get 2 is less than or equal to 6, which is true, which means this first inequality is the second inequality that makes up the system. Notice how if we substitute 2 for x and 0 for y here, we get 2 is greater than or equal to 6, which is false, which is the reason why the second inequality is not the correct inequality. So when the inequality is not solved for y, we do need to select a test point to determine whether we would shade above or below the graph. I hope you found this helpful.